Hey guys, how are you doing today? So I'm back. So we're going to start building on factoring today. First we had worked on how to factor basic quadratic trinomials. Then yesterday's lesson we added on where sometimes we divide out a GCF out of the equation first, and then we can go ahead and factor and solve as needed. But today we're going to take a step further and we're going to work on some more greatest common factor factorizations. So greatest common factors can be just like a number like we were working on yesterday, like where you divide everything by 2 or 3 or something like that. But they can also include variables. And sometimes when you factor out a greatest common factor, then that's as far as you go. There's nothing else for you to do after that except for maybe solve or something like that. So let's take a look at factoring out these expressions here. Now you'll notice that these expressions here are all binomials. So there's just two terms being separated by that plus or minus sign. And especially in number one, there's not even any type of numerical term. There's just variables there. So when you want to take out a greatest common factor that has a variable or includes a variable, you just want to look for the common variable. So if you look at number one, okay, when we have number one here, we notice that we have an x in each of our terms. So that is our greatest common factor. So just like we were doing yesterday with the numbers, we would divide out that x. Now, whatever number we're dividing out by, or in this case, we're dividing out by a variable, that is going to go outside the parentheses, and then whatever is left would stay inside the parentheses. So if you have xy and you divide it by an x, you're left with just the y. And if you have x times z and you divide it by x, you're left with just that z. And the way to check your work is to distribute back to see if you get back to your original. So if I were going to distribute back here, and I were to multiply the x times the y and then the x times the z, I would get back to my original problem. So let's take a look at number two. So now number two, there's numbers on both of these terms. We have a 9 and a 3. So part of my GCF is going to be the GCF of those two numbers, which is 3. So remember, greatest common factor is the largest number that both of those can be divided by evenly. Then you look at your two variable terms. So we have an x squared and an x. So again, what's the largest amount of x's that you could divide out of each of these? So whenever you have two of the same variable, whichever one is smaller would be your GCF. So if you have an x squared and then just an x without a power on it, which is really a power of 1, it would just be the x. So now when we write our answer, we write the 3x, which is the GCF outside the parentheses. And then when we divide each of those terms by that GCF, whatever's left goes inside the parentheses. So 9 divided by 3 is 3. And since we had an x squared divided by an x, you're really like subtracting those exponents. So you're left with 3x there. And then 3x divided by 3x would just be 1. And then that sign's just going to stay the same. Now again, to check it, if you did 3x times 3x, you would get 9x squared, which is what you had up here, and 3x times negative 1 would give you that negative 3x, which is up there. So that's how we can check it. So let's look at the next one. Now the next one, we have 21 and 15, but what is the greatest common factor? Now again, you can use the factor sheets that I provided for you on Monday on Google Classroom. So 21, your factors are 1 and 21, or 3 and 7. For 15, you have 1 and 15, or 3 and 5. So which factors do they have in common? Obviously, everything has a 1 in common, so that's not really helpful. But of the other options, they both have a 3. So that's the greatest common factor that we can divide by here. Now look at your variables. Do they have any variables in common? Well, this one has a b and this one has an a. So unfortunately, there's no common variables. So the only GCF we can divide out here is 3. So 21b divided by 3 leaves us with 7b. And 15a divided by 3, or you could say negative 15a divided by 3 is negative 5a. And again, if you want to check your answer, just distribute that 3 back in and see if you get back to where you started. So moving down to the next couple examples. Okay, so number 4, we have 27 and 18. So again, use your factor sheet if you're not sure what all the factors of 27 and 18 are. So 1 and 27, 3 and 9. And then for 18, my factors are 1 and 18, 2 and 9, 3 and 6. Now notice, when you look at these two numbers, you have a GCF, or common factor, I should say, of 3. They both are divisible by 3. But they're also both divisible by 9. So there's 2 common factors. Well, that's where the G in GCF comes in. It's the greatest common factor that you want to divide out if you're going to factor this completely. So we would have to pick the 9 here. Then you look at your variables. If we have a y cubed and a y squared, they're both y's, which is important. But then when you're looking at the same variables, whichever exponent is smaller, that's the one that can come out. So 9y squared. So 27y cubed divided by 9y squared. Well, 27 divided by 9 is 3, so the numbers divide just like they normally would. And then y cubed divided by y squared, if you subtract the exponents, you are left with just that y. Then on the other side there, you got 18 divided by 9, which is just going to be 2. And the y squared divided by y squared would cancel, so you're just left with 3y plus 2 in the parentheses. Okay, let's take a look at number 5. So for number 5, we have 12 and 16. Again, if you need to, use your common factor chart. So for 12, you got 1 and 12, 2 and 6, 3 and 4. For 16, 1 and 16, 2 and 8, 4 and 4. So what is the greatest common factor? Well, we can see that they have a common factor of 2. They also have a common factor of 4. So of those 2 choices, 4 would be the greatest common factor. Now let's look at the variables. We have an x squared and an x. So which of those is smaller? The x. So that would mean that 4x is the greatest common factor for this binomial. So now we're going to divide each of our terms by 4x. So 12x squared divided by 4x. Well, the numbers you do normal. So 12 divided by 4 is 3. And then x squared divided by x would just be x. Then when you look at the 16x divided by 4x is 4. And the x's would cancel. So it's just 3x minus 4 in your parentheses. For number 6, 28 and 7. Well, the only thing 7 is divisible by is 7. And 28 is also divisible by 7. So that's our GCF for the 2 numbers. And then you have x to the 5th and x squared. So x squared would become part of our GCF. So 7x squared. So now 27x to the 5th power divided by 7x squared. Well, 28 divided by 7 is 4. But if you have an x to the 5th divided by x squared, you subtract your exponents and you get x cubed. Negative 7 divided by 7 is negative 1. And x squared divided by x squared, they would cancel out, so you don't have any more x's left there. So now moving up to the next 3 examples here. This time you might notice that we have more than one variable in each term. So our first term here has an x and a y, and the second term also has an x and a y. So in this case, not only can we take out a numerical factor and a variable factor, but we can actually take out more than one variable on our GCF. So again, take it one step at a time. First, look at your numbers, 2 and 2. Well, obviously our GCF there would be 2. Then look at your x's, x squared and x. Which one's smaller? X, so that's part of your GCF. Then look at your 2 y's. Well, they're both a single y, so you can take out a y as well. So then your GCF is actually 2xy, and then let's divide by that and see what's left for our parentheses. Well, 2x squared y divided by 2xy, the 2's would cancel, the y's would cancel, and x squared divided by x, if you subtract the exponents, you're left with just x. On the second term there, minus 2xy, we're dividing that by 2xy, so we would just be left with that minus 1. And again, if you want to check it, you can distribute the 2xy to the parentheses, and you should get back to the original. So let's take a look at number 8. 8 and 16, what's our GCF between 8 and 16? 8. Both of them are divisible by 8. Then you have m cubed and m to the second power. The smaller of those m's would be part of your GCF. And then the first term does not have an n, but the second term does. So n cannot be part of our greatest common factor because the first term does not have any type of an n. So our GCF would just be 8m squared. So now when we divide each of our terms by 8m squared, 8m cubed divided by 8m squared, 8 divided by 8 is just 1, so they cancel out. M cubed divided by m squared, 3 minus 2 is 1, so you're left with just m to the first power. Then on the second side of the equation, you have 16 divided by 8, which is 2. And m squared divided by m squared would cancel, but you still have that n, which is going to be included on that term there. Again, if you need to check your work, if you multiplied 8m squared times m, you would get 8m cubed. If you multiplied 8m squared times 2n, you would get 16m squared n. So that would be how you check it. And finally, we have our last problem here, number 9. So we have 3 numbers this time to find the GCF for, 4, 2, and 8. All of those are divisible by 2, and they also all have some form of a b variable. So the smallest of the b's is just that single b there, so 2b would be our GCF, and then we're going to divide each of those terms by 2b. So 4b cubed divided by 2b would be 2b squared, because 4 divided by 2 is 2. B cubed divided by b, you subtract your exponents, you'd be left with b squared. Now let's do the middle term here. 2b squared divided by 2b, well, the 2's would cancel, and b squared divided by b leaves you with just 1b. And then the last term, 8b divided by 2b, 8 divided by 2 is 4, and the b's would cancel, so you would be left with 2b squared plus b plus 4. So now let's go on and build on to this a little bit. So now if I'm looking at this next page, I'm going to factor these expressions completely. So when I'm factoring completely, that means that I'm going to always check for a GCF first, no matter what. So no matter what the problem is, binomial, trinomial, whatever, you always want to check for a GCF first, and if there is one, factor that out first. Then you want to look in your parentheses. If you still have any more terms with exponents, you want to take a second look at those to see if there's any more factoring that you can do. Sometimes there is, sometimes there isn't. So let's take a look. So our first trinomial here, we do not have any common number terms that we can divide out, because the first term, this is really just a 1. So the greatest common factor of that is just going to be 1. So no numbers can divide out. However, we have an x cubed, an x squared, and an x. So they all have an x in common. So the smallest of those would become our GCF, which is that single x. So I'm going to divide out just an x from each of my 3 terms. Now remember, when we're dividing out variables with exponents by other variables, we're subtracting the exponents. So x cubed divided by x would leave me with x squared. 3x squared divided by x will leave me with 3x. And 2x divided by x is just going to leave me with 2. Now this trinomial that we ended up with here might look a little familiar to what we had been working on the last 2 days. When you have a quadratic trinomial with just an x squared in the front, you can split that x up into each of those 2 smaller parentheses, and then you're looking for the factors of 2, or the 2 numbers that multiply to get 2, that add up to get this 3 in the middle. So the only factors of 2 are 2 times 1, and positive 2 and positive 1 add up to 3, and they multiply to get 2. So this would be our complete factorization of that trinomial. So let's take a look at number 2. Number 2 is a binomial again. So the only thing they have in common here is 2. So we're going to divide out the 2 from each of our terms, leaving us with b squared minus 1. Now this is a little bit tricky, and we're going to get into this probably next week. So nothing like this will be on our quiz this week, but just to kind of give you a little preview, something like this is really b squared plus 0b minus 1. That's really what we're looking at there. So if you wanted to finish factoring it because you see that there's a b squared there, you'd have to say what numbers multiply to get 1 and subtract to get 0. The only numbers that multiply to get 1 are positive and negative 1. And that's what it would actually look like. But for our purposes now, if you just got to this first step, that's okay, because we haven't really gotten into the special factors just yet. We will be getting there, though. All right, so let's take a look at number 3. Another trinomial. There is no common factor number here, but there is a common factor variable, which would just be a single a value. So we take out the a value from the entire trinomial, which reduces each of these a's by 1, right? So this a cubed is going to become a squared. The 9a squared will become 9a. And the 14a will become just 14. Then, because it is a quadratic trinomial, you want to see if you can factor it into 2 binomials. So a squared will break up into an a and an a. What 2 factors of 14 add to get 9? 2 and 7. Since it's a negative 9, it's a negative 2 and a negative 7. So this would be our complete factorization of that trinomial. Let's take a look at number 4. So this time we have three various n values. The smallest of them would be n squared. So this time our GCF is actually n squared. So when we divide each of these terms by n squared, we're subtracting the exponents, so they're all going to decrease by 2. So n to the 4th divided by n squared is going to be n squared. 2n cubed divided by n squared is going to be 2n. And negative 3n squared divided by n squared will just be negative 3. And then again, we have a quadratic trinomial, so we're going to attempt to factor that a little bit more. What factors of 3 subtract to give me a 2? Well, 3 minus 1, right? Now, because this is a negative, I know I have 2 different signs here for the 3 and the 1, and this negative on the 2 tells me the bigger number will get the negative, the smaller number will get the positive, and this would be my complete factorization for that trinomial. All right, so we're just going to do a few more of these. We got 6 more, and then we'll be done for today. So number 5, you might look here, you got 7, 21, and 14. And you might notice that all 3 of those numbers are divisible by 7. Now, whenever your lead term has a negative on it, you need to take that out on your GCF. There is no common variable here because even though the first term and the middle term here have x's, the third term does not have any version of an x, so you can't take out x as part of your GCF. So it's just the negative 7. So when we divide each of these by negative 7, the signs will change. So negative 7x squared divided by negative 7 is going to be positive x squared. Then positive 21x divided by negative 7 will be negative 3x. And then negative 14 divided by negative 7 will be positive 2. And then we want to see if we can factor that a little bit more, splitting up our x squared into x and x. What are the 2 factors of 2 that add to get 3? 2 and 1. And since they're adding, the signs are going to be the same. Since this is a plus, it's a negative 3, so they're both going to be negative. And that would be our complete factorization of that trinomial. Okay, number 6, we're looking at another binomial here. So there is no common numerical term between the two because it's just a 1 and a 4. So we can't divide out any numbers per se, but there is a negative here. So we have to at least divide out a -1 to get rid of the negative on that lead term. Then they also both have versions of x's. The smaller one would go on our GCF. So our GCF is actually just -x. If you want to make it -1x, it's the same thing. So -x cubed divided by -1x is just going to be +x squared. 4x divided by -1x is going to be -4. Now this is one of those ones that, because this 4 here is a perfect square, just because there's nothing in the middle, that really means there's a 0 in the middle. So what two numbers or factors of 4 subtract to give you nothing? Well, 2 and 2. And you would have to have a positive and a negative. And again, we're going to do some more of those probably next week. Okay, a couple more here with some multiple factors. So 36 and 64, the largest number there is, let's see, we might have to write these down. So 36, I've got 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. For 64, I have 1 and 64, 2 and 32, let's see, 4 and 16, 8 and 8. So what is the largest or the greatest common factor for these two sets here? So looking through, I got 36, no, 32, no, 18, no, 16, no, 12, 8, 9, 6. What do we see here? A 4. Anything greater than 4 in common? I don't see anything. So we're going to divide these both by 4. Now let's look at our variables. What variables do they have in common? Well, the first term has an x squared, but the other term does not have any x's, so we can't take out any x's, but they both have a y. So you're going to divide out a 4y as your GCF. 36 divided by 4 is 9, and then we're still going to have that x squared there. Y divided by y will cancel. 64 divided by 4 is 16, and the y's will cancel. So this is what I'm going to allow you to leave for now for those. Again, this is perfect square, so I'm just going to say for bonus, if this would actually be 3x plus 4 and 3x minus 4, but we're not quite there yet, so don't worry about that part. Okay, number 8, 12 and 3. We're going to divide out a 3. They also all have a c, so we're going to divide out 3c. We cannot divide out a d because only the first two terms have a d, the third one does not. So when I divide out my 3c, I'm left with d squared plus 4d plus 4. So now d and d, what are the two numbers that multiply to get 4 and add to get 4? 2 and 2. And that would be it. Now, because I have the same thing twice, if you get that, then you would just write it once and you would put a little square on it because that means that it's multiplied by itself 2 times. All right, last two problems. Oh, sorry, I lied. There's 4. Okay, so we're going to divide by 3 here. That's the only thing in common. There's no common variables for number 9. So we're dividing everything by 3, which leaves us with b squared plus 4b minus 21. And then we want to factor that trinomial into b and b. The two numbers that multiply to get 21 and subtract to get 4 are 7 and 3. Because this is a negative, we know the signs are different, and this positive in front of the 4 tells me the bigger number is positive, the smaller number is negative. Okay, number 10, GCF of 2, 6, and 4 would be 2, and all 3 of them have some version of an x. The smallest one is just a single x, so our GCF is 2x. So after we divide out 2x from each of these, 2x cubed divided by 2x is just x squared. Negative 6x squared divided by 2x is negative 3x. And 4x divided by 2x is 2. And then that trinomial can be broken down a little bit more. The two factors of 2 that add up to get 3 are 2 and 1. Because it's a plus here, we know the signs are the same, and this negative tells me that they're both going to be negative. So that would be my complete factorization. And then finally, number 11 and 12. So number 11, all three of these numbers can be divided by a 3. And of course, since the lead term is negative, that negative needs to go on the GCF as well. Then we're seeing that there's a common variable here. All three of these terms have a k. The smallest of those k's is k squared, so that is also part of your GCF. So your GCF is negative 3k squared. So now negative 3k to the fourth divided by negative 3k squared, well, the negative 3's would obviously cancel, and you subtract your exponents to get a k squared. 18k to the third divided by negative 3k squared is negative 6k. And negative 24 divided by negative 3, you're going to get a positive 8, and the k squares would cancel. Then we take a look at our trinomial, see if we can take it one more step. The two numbers that multiply to get 8, that add to get 6 are 2 and 4. Because the signs have to be the same, and this is a negative, they're both going to be negative. So our final factorization there is negative 3k squared times k minus 4 times k minus 2. And our last problem, they're all divisible by 8, and we have to put the negative on that 8 because our lead term has a negative. Then even though the first two terms have y's, the third does not, so we cannot take out any part of a y. But all three of them have a single z, so that can be part of our GCF. So we're going to divide everything by negative 8z. So negative 8y squared z divided by negative 8z, the negative 8 and the z would cancel. We'd be left with y squared. Then this middle term here, this negative 40yz divided by negative 8z would give you a positive 5y. 40 divided by 8 is 5. The z's cancel. And then the 48z divided by negative 8z, the z's cancel, and 48 divided by negative 8 is negative 6. And then we look at that trinomial. We look to see if we can factor it into two smaller binomials. The two factors of 6 that subtract to get 5 are 6 and 1, positive 6 minus 1. And that is how you factor out a GCF first and then finish factoring, and that is what it's called when you factor completely.